exemplar examples today, and also look at some student work, right? That good? All right. Do you have any volunteers who would like to start off for me?
Let's start.
Okay, cool. You're putting up your exemplar, right?
Yeah.
All right.
So, in this standard, we will have the, this is, the ICANN statement for this is all properties, applying all properties of exponents, and simplifying the expression also.
Okay.
So the first problem in the exit ticket is they need to simplify that one, and or the equivalent expression for that, for this expression for the exponent.
Okay.
So what they're going to do is they need to use all the properties. So they need to use the power of product.
Okay.
Okay, so for this part, they need to simplify it. So when I say power of product, they need to distribute the negative 3 to each term inside the parentheses.
Okay.
Okay, so there are two expressions here inside. So we need to simplify. I told them you need to simplify it step by step. So we can have this first and then followed by the second, so that they will not be confused at first. So we need to distribute the negative 3 to 1/2. And then we need to distribute. When we say distribute, we need to multiply. So 3 times, it's a negative, so negative 3 times 2 is negative 6. Why I did not simplify this yet? Because I have negative 3 inside, so I need to flip. There is a rule for this one here.
Got it.
And then y, negative 3 times negative 3 is 9. And then the x, negative 8 times negative 3 is positive 24. And then the same of this rule, we will distribute it here, each term. So 3 to the power of 2 is multiply the 3 2 times, so it's 9. Then x, negative 5 times 2 is negative 10. And then the y, 4 times 2 is 8. And then for the z, 8 times 2 is 16. So this is what we call the power product. Or simply as you need to distribute the exponent. I think they are familiar with this distribution.
Gotcha.
Okay, so after that, I told them there is also another properties. If there is a negative, they need to flip it. They need to switch it. So for example, I have the power of here is negative 3, the power of here is negative 6, so they need to flip it. So they need to switch it. So this is what they need to do or use the negative exponent. So I gave them anchor charts for them to see what's the difference of all the properties. So they
Gotcha.
have that one in the board, they have that one also in their notebook.
Mhm.
So I have 1/2, get the inverse or get the, or flip it, so it will become 2/1 or simply as 2 to the power of 3.
Mhm.
And then this x to the power of -6, so it will become 1/x to the power of 6. So this one, nothing to do because it's positive, so I'll just write it down. Or I can simplify everything here, so it could be like this, a power, all in all. So all the positive will be in the numerator, the negative will be in the denominator.
Mhm.
So for this part also, the one that I will flip is this one, the negative. So when I say flip, it will be in the denominator. Because I told them, if this is the expression, always remember there is over 1 for this.
Mhm.
So this one, no negative for this term, 9, 1 to the y to the power of 8, z to the power of 16. So just simply copy. Oh. Z to the power of 16. Okay. So this time, I have the properties already. Since we still have like terms or common terms, I need to simplify this one. And also, I can simplify the 2 to the power of 3. So in this part here, for this side, they will use quotient property. In which, when we say quotient property, they need to minus the exponent having the same term or the same variable. So they need to subtract their exponents. So they have the same basis. If they have the same basis and it is a division, they can subtract their exponents together. So since I don't have y below, then I don't have, I know it's only a number here, so I need to simplify this one. So 2 to the power of 3 means multiply 2 3 times. So 2 times 2, 4. 4 times 2 is 8. And then copy the y over 9. I can simplify 8 times 1 to 8. Then here, x, I will subtract it. So 24 take away 6 is 18. Yeah. And then close it. Then after this, they need to find, or we need to find the same basis. Since we don't have the same basis here, so automatic, just copy everything. So 9y, 8z, 16, x, 10. Then after this, they need to multiply numerator to numerator, denominator to denominator, and after that, they need to use the product of powers, in which they need to divide. So we need to have numerator or multiply numerator to numerator, denominator to denominator. The question is, Miss V, I don't have denominator. That's their automatic question. I told them when there's a whole term, automatic, there is imaginary 1 below.
Mhm.
So they have to multiply it, multiply the coefficient here to the coefficient, so they got 72. Then they need to look at the terms that have the same basis. And then if we say product of powers, they need to add the exponent of that term, of that base, of that the same basis. So in this side, we have y. We have also y on this side. So I can combine them. So I can add 9 and 8. So 9 plus 8 is 17. And then x, I don't have. And then z, I don't have also. So I need to copy over 1 times x to the power of 10 is x to the power of 10. Then this time, they need to check what else that can be simplified.
Mhm.
So as they notice, they still have a same basis here, a term that have the same basis. So it's the x and the x down. So that they need to go back to the division, a quotient property. So instead of adding when it's division, they need to minus. Then where wisdom subtraction happen, it will happen on the numerator, not in the denominator. Why? Because 18 is bigger than 10. So for the final answer, they got 72. I don't have y, so I need to leave a space because I need to write the term, or I just did not tell them to arrange Mr. Perry, but they need to know that it may be arranged into alphabet X, Y.
Yeah.
Yeah, but I just accepted their answer since they have the correct powers out of it.
Gotcha.
So y to the power of 17, then x, we minus 18 to 10, so we got 8. And then copy the z to the power of 16. So this is their final answer. So in this side, we have the quotient property. Those are the steps. They are still confused, Mr. Bear, about that, if it's very long.
Well, I'll tell you this. One of the things you did, you broke it up into sections, right? And you named the purpose behind each section. Alright, so I thought that was pluses. And then the way you have it kind of organized, this section, use the power, right?
Yes.
I would also, my suggestion also is to add why you're doing it, right? And part of it, like, it could be from here to here, you getting rid of the negative exponents, kind of right here, okay? Combining like terms, I like how you explained that. And then also in your anchor chart and or in your exemplar, you mentioned the misconception, which is perfect. Just jot them down because you know they're not listening to every word you're saying, right? And some of our kids are listening to every other word, so while they're writing, they miss the one of the misconceptions. So maybe having a section where it has that misconception will help them. But I think it's beautifully done step by step. If they feel like it's too long and you're not getting to the right answer, then break it up. Have them do half or give them a problem where, you know, you have this, and this part is out, that part is out, and they have to fill in the blanks, or do this part, give them different sections, and that'll give them an opportunity. Look at Washington. He should know all of this stuff while he's looking around at this PLC. But very good job, Ms. B. Very good job. How did it feel like giving them an exemplar? How do you feel like they're progressing when they say, all right, this is like, 'cause this is a lot for one problem, right? So how do they feel about when you're presenting and showing them, all right, this is all I need, this is what I need you to do for this problem?
So sometimes it's they will say it's a lot. Then aside from that, they can follow, if ever I put this one, they can go directly or refer to their notebook and then they will check on how to do it.
Gotcha.
So they have the steps already.
Because I would say for us, we, that was roughly, I would say that was roughly 10 minutes,
Yeah.
right? Which is about the amount of time we want for an exit ticket, right? But at the same time, if in 10 minutes they can give me all of this, they have a clear understanding. So you've given them a good problem. The rigor is up. It's just those little tidbits things, okay, that we gotta give them to kind of get them over the hump. And we gotta increase their capacity for doing this. Because this is legit a problem that they'll see on their ELC. They got 59 more of those, right? And then how much time do they have to take to the ELC? So some of it, we've got to be like, all right, you're getting all of this done. But also explain to them, you're doing all of this for practice, but the ELC might ask you, what's that?
Yes.
Very rarely are they going to tell you to go all the way down there. And if they do, they've got multiple choice, so you got some options. But very, very good exemplar example. Those little things that we'll do. And then I like how you also mentioned the anchor charts, okay? What I want us to eventually get back, which we did a little bit last year, but not with an exemplar, is we're gonna role play, like we'll be the students, and the teacher's gonna be up here and role play how she presents the exit ticket, the exemplar example, okay? All right, very good job, thank you.
I have two problems and only one is correct. The
Oh.
other one is a problem solving.
All right,
But it's just simpler.
well, let's let's try that one. Let's go ahead and try to work on that one.
Yes. The problem is, given the width of a rectangle, which is 5x squared y squared inches, the length of the rectangle is the width cubed. So find the length of the rectangle, what is its area, and they need to show the work. So they need to find first what is asked in the problem. I told them, okay, what is asked in the problem, they need to find the length of the rectangle and what is its area. Now, if you say area, you need to find out what is the formula. Scan your notes, because we have already discussed formulas before. So what is the area of a rectangle? So it's in their notes that the area of a rectangle is length times width. And then after that, they need to go back to the problem. Since they got already the formula of the rectangle, they need to identify their width, they need to identify their length. So they will go back to the problem. So go back to the problem and read it again, repeat it until you understand what is the width and what is the length. So it states there that in the problem, given the width of a rectangle is 5x squared y squared. So automatic, that is the measurement of our width, 5x squared y squared. And then next, go to the next sentence. The length of the rectangle is the width. So go back to the width. This is your width. Remember, cubed. So we have this word, vocabulary, which is the cube. And we know what is also a square. Let's review. Square is, the number is 2. So how about when we say cubed? So this is a 3. And these are what we call the exponents, or the power. So let's go back to the sentence. The length of the rectangle is the width cubed. So they need to give the expression out of it. So the length or the measure of the width, which is in cubed. So we found the area. This is our, not the area. We found the length, which is this length. The first question. Let's go to the second question. So the second question is we need to find the rectangle. This is not the rectangle. Oh. This is our length. Okay. So let's go back to the formula. We need to apply what is the length and what is the width. So A, area of a rectangle, is equal to length times width. And then this time, you need to substitute or replace what is your L and what is your W. So go back to your what are givens. So here, the length is 5x squared y squared cubed multiplied by the width, which is 5x squared y squared. So if they're looking at it, they are going to apply all the properties again. So go back to their anchor chart or to their notes, and they need to identify which what would be the first step or what property that they could use on this. So in that case, they need to use the power of product. So when we say power of product, the same thing in number 1, what they did, they need to distribute this one first. So we have 5 multiplied it 3 times. So 5 times 5 times 5 is 125. And then for this one, when they say exponent, just multiply automatic the exponent and the power outside. So 2 times 3 is 6. And then 2 times 2 is 6. Okay. And then since they don't have a power here, so they just need to write it down. No need to say it. Okay. And then after this, they need now to simplify or combine the like terms using another property. So out of that example, they will use the product of powers. So in which they need to find the same bases. And then they can add, since this is multiplication, so they need to add the bases, which have the same letters here.
So for the numbers,
they need to multiply only, so this is
600.
625. And then
Since they have the same term,
XX, so just add the numbers, 8.
and then for the y, same. Still, since they have the same bases, so they can add 6 and 2, and this is 8. And then let's go back to their misconception. They will be confused on getting the length because
I don't know if they know the cube. That's why I told them you need to review those vocabulary, the cubed.
the square, so that they can understand the lesson.
So therefore, the area of a rectangle is 625 x to the power of 8 and y to the power of 8. So this one is right. So usually they will be confused in how to get 5 and this one. Usually they have multiply 5 times 3 automatic. They will do it the
Same as what they did with
the letter. I told them when it comes to the letter, just multiply the exponent with the power outside. But when it comes to coefficient, you multiply it how many times by itself according to the power outside. So 5 times 5 times 5.
That's their misconception usually, Mr. Berry.
Gotcha.
That one.
And just explain to them, like, you know, what does it mean, right?
Yeah.
So, like,
They
for
can
example,
expand also.
yeah, you just like the expanded version.
Yeah.
You know, that just means 5 times 5 times 5. We can answer that when it says x squared times x squared times x squared.
And add the numbers.
We put that in the calculator, it's gonna give us an error message. We know based on the power. It's very good job. Very
I
good
open
job.
up to them.
The expanded one, Mr. Farr. So I told them you can use expanded form, you can use the shortcut form. But they said we're okay with shortcut.
Gotcha.
Don't like to write many.
Yeah, I can understand that. If they think this is a lot, can they imagine that?
Yeah.
This actually is even more relatable to them because it's putting it there. Now, let me ask you a question. Do they draw the rectangle?
No,
or
Mr. Berry.
Okay,
The given
It's only the width that is given.
gotcha.
Yeah.
I would suggest that's a good option for them to make sure that
they know.
they draw it because, you know, just putting that visual there. I think that putting that visual there helps them even further understand, you know, when
And,
stuff like that. Okay, very good job. Very good job. All right. All right. Who would like to go next?
Check with their work, Mr. Berry.
It's okay, so just from the word.
Oh,
It's okay. So it's okay that they need to, no need to identify the property this time.
yeah. If you didn't ask them to do that, that's fine. All right. It's just a good practice, especially, I would say this with the exemplar, you know, if you put it up there, you wanna like tell them, hey, I expect this up there. But if in the end game, you know, you don't need to take points off if that's not something that you wanted them to do.
So for my topic, it's our plan. And before we started, during the discussion, I gave them the formula. So that's S equals R theta, where S is the arc length.
R is the radius.
And theta is the angle, but it should be in radians. And I also told them that they can only use the formula if the given angle is in radians. If it's in degrees, they have to convert it first before they can use the formula. So the first item, a circle has a radius of 2.4 inches. So a circle has a radius of 2.4 inches. Find the radian measure of a central angle that intersects an arc length of 12 inches. So that intercepts an arc length of 12 inches. So for number one, the unknown for number one is this angle here. Now since we are looking for the angle, we don't have to convert anything anymore. We can go directly to the problem. So to the formula, S equals R theta. The given is So I also informed them that before you start solving, you have to identify what the given is first. So we have arc length, which is 12, radius, which is 2.4, and you have to find the theta. So S is 12 equals R 2.4, and then they have to find theta. So in order to find theta, how do you do that? Divide both sides by 2.4, and I'm not sure what the answer is. 12 divided by 2.4, can you do it? Oh, I think they have the answer there. What is it, 5?
So we're racing. Everybody's racing.
So theta equals 5. And some of them, since it's in radians, the unit should be in radians as well. Well, there are some students who put the unit which is in inches, which is wrong, so I corrected that. There are students who just kept 5, and I corrected that as well, and then applied some points, so it should be like 5 radians, because that is the angle that we're looking for. That's the angle. Not inches, not cm or whatever. So that's for number 1. For number 2, we are given a circle, and then for number 2, the circle is this. To 10 and then 15. So our given is R equals 15, and then the theta is 210, and we need to find the arc length. Now, since our angle is in degrees, they know that they can't use the formula right away. They have to convert 210 to degrees, to radians first. So in order to do that, they'll multiply it with pi over 180. And then they will just simplify 210 over 180. They need to find the greatest common factor. What can we multiply to both? Well, I told them, Mr. Perry, that if you don't know what the greatest common factor of the two numbers, we can do it step by step. They can probably divide this by, what do you think? What can we divide with 210 and 180?
30. We'll start off with 2 because they're both even.
Oh, okay, 2. We'll start it with 2.
2 or 10. There's a 0 at the end. Either
So
one.
I always tell them, if there's 0 on both of them at the end, you can always start at 10.
Yeah.
So, yeah, let's try 10. 10 over 10, so 210 divided by 10, that is 21. 180 divided by 10, that is 18. And then, is this the simplest form already?
No.
Not yet, so we can still divide something from the two numbers, which is?
3.
We can divide 3 for both of them, so 21 divided by 3, that's 7. 18 divided by 3 is 6. Do you think that is the simplest form already? If they say yes, so that's going to be the final answer, but don't forget to put pi there. So this will be the angle that we'll use now instead of 210. So we'll use 7 pi over 6. Now, if you already have the angle in radians, that's the time you use the formula. S equals r theta, where r is 15 and theta is 7 pi over 6. And then I just asked them to use the calculator for this. So 7 pi, do you have 50? What is it? 54. And the unit in radius is inches, so we have to follow the unit of the radius. So the final answer here will be 54 inches.
Very good work. There's a lot of anchor charts that they would need for those, right? So you want to make sure you put the anchor charts on the outside. Kind of, sort of. I didn't see the time. I was trying to catch up and stuff. So come on, catch up on. Come on in. You know that you're more than welcome. All right. So yeah, obviously they would need some anchor charts accessible to them. I like the way you did the misconceptions. I actually like this example as well because it adds a step of the degree to radian part. And because then you can identify another issue that they're particularly having.
are they having the trouble with the radians to degrees or degrees to radians peak? So that's good. You know, again, also with this, you wanna make sure they have Desmos available to them. Any shortcut to Desmos that will help them understand it would be great. But I think you did a great job. You hit on each part. I like your demonstration. That's something that we're gonna practice and work on is once we get our exemplar example, how we present it to them. One of the things that I think both of y'all have done so far is explain your thinking pretty much, like why you're doing what you're doing. So we wanna keep that, you know, make sure we, are focusing on making sure we keeping that understanding and look at how much stuff that you had to pull that they've done in previous classes or early in the year, like greatest common factor, simplifying, right? Knowing what pi is, arc. One of the things that Ms. Valmori did also is kind of talk about the vocabulary that they need to do. One of the things I forgot because I didn't want to interrupt you. In English and social studies, they're talking heavily about annotation. And so when you guys are talking about your questions and breaking it down in each question, you know, it might be helpful to tell, hey, you can annotate your math questions too, because they have that understanding of what annotation is, right? And it'll help them, and that's just another practice that goes for English social studies class, they now can incorporate in math class and help them out. All right, well, good job there. Thank you. We'll keep working on. Interested to see how they did with that. Ms. Shaw, you ready?
You ready?
Christian, you go first.
Go with it. Just do it. I just can't watch you and
Let me just
Have
write.
you found a boyfriend yet?
It's coming out gunning, right?
Let's not talk about that here.
I read getting this up and all that. I would not write this on this whole thing. And then,
Yeah, shortcut. So that's our anchor chart.
Oh, okay, gotcha.
This number one. Also, I have also the parts of a right triangle. This is the hypotenuse. This is our opposite. Okay, those are the anchor chart posted on our board.
Gotcha.
Okay, in number one question, we are finding the side x here. But I tell them to label the triangle first. So if this is our given angle, what do you call the x then? It's opposite.
Opposite.
Then what about the 3 here?
That's the adjacent.
How can we find the adjacent? Christian, it's actually next to the given angle, and it is always in between the right angle and the given angle. Then, therefore, if we have adjacent and opposite, what among these 3, which do you think is the triangle which are we going to use?
We have opposite and
And
adjacent. TOA or SOA?
We'll have tangent then. Tangent 37. It says opposite. What's our opposite side?
X.
Our adjacent.
3.
And our goal is to get x. So how can we get x to there? We need to put the imaginary one there,
Mm-hmm.
and then
Cross multiply.
the butterfly method. We call that butterfly.
Okay.
And then x times 1 is x. And then all you need to do is to put them together because we cannot do that manually.
Mm-hmm.
Right? And then just put everything on the decimals. Approximately that is all you need to do is to put 3 and then click the function on your decimals and then 37.
Gotcha.
And it will give you exactly the 2.26.
Okay.
Next. Number 2 is actually a word problem. It says the angle of elevation from a point 116. Since it's a word problem, I told them to underline the hints in your word problem.
Okay.
Like a point. So there's a point and there's an Eiffel Tower. I'm gonna draw the Eiffel Tower. Then we can create our triangle. It says 116 from the base. So where do we put the 116? Is it on the high, the slanting, or on your base?
At the bottom.
Correct. 160. And then it says angle of elevation. Since we are dealing with 2 angles, we have elevation and depression. Which one do you think is the angle now? The first or second?
Elevation. We went from the bottom to get at the top or something.
Let me try. And then the question is find the approximate height of the tower. So since the height is missing, what letter shall we use here?
That is the,
X and G. And then
yeah, we have the opposite and we have the adjacent, so that'd be tangent again.
correct. So first thing first, you have to label your triangle again. This side is outside. And
Opposite,
then
adjacent.
so since we have O and A, which one has O and A there? Tangent. Just like what we do here. Tangent. What is your opposite? X. And then your adjacent. For us to get your X again, write the imaginary one here. Do the butterfly method.
Butterfly method.
And that's the 3. In writing this, sometimes they are
160.
writing tangent 67, 116. But I always ask them to write the constant alone, and then the tangent.
Yep.
So
Treat
they
like
will
it's a
not mix up.
coefficient. Very good.
And just a constant.
Great
So
job of
7.
pointing that out too.
273.3.
273. Others put decimal also there.
0.33.
Point 3.
That's
Very good, very good. Great job of making sure they're labeling it, because that helps identifying where the misconceptions are. Good job also providing each one of the anchor charts and referencing them. Another thing about the presentation, this is a good job as far as creating the exemplar. Another good thing that I thought was like, when you're presenting it to them, the stuff that they already know or review, ask them and have them tell you, instead of you filling out. What you wanna do when you're doing to the exemplar, show them the new part or the muggy parts and stuff like that. But always lean on them for the stuff. This is the part you already know. Because not only does it kind of, keep them engaged in the discussion about this problem, but also, recalls them to remember what they did. And I find it beneficial for the students if you identify what's new. Like the majority of this stuff, guys, y'all already know. This is the part that's new to you, right? This is the new part that I want you to work on. So, very good job. And you can, like I said, you can break this up in components, because that is a lot for them to do in one setting, but you're breaking it up in components. And again, that was another, 10 minutes there? So, yep, great job, great job. Mr. Chris, you got anything for us? You gonna teach us a little biology today?
You have to.
Is you know?
I mean, I came to make copies. I saw you here. I was like, let me just walk in there. Well, this is what we are yet to do, but we'll do it the next day.
Alright, and this is perfect because, we're math people, so if you teach us some biology, that'd be great.
Okay. Anybody know their blood group?
Blood group?
You know your blood group? You don't? What's your blood group? You're O.
You're the rarest.
Oh,
Look, what is it? One, O positive is the one that's like the rare. One is the rarest, and the
You know
other one
you?
can be used for everybody.
So you have to
Usually
take
we're all
The most common is O plus, and O negative is the one of them.
Anybody AB? You know?
You know, I know.
Why is everybody O? You're in
Because it's the most
trouble.
common.
But you're in trouble.
Why?
Because you can actually give blood, like you can easily transfuse blood to everybody, but you can only receive
The
blood.
most common, not common, AB?
Yeah.
Okay.
The most common is AB.
AB.
The least common
The least common is AB.
is the least common.
Yeah. But why you are O? So what happens if there's an
I
accident?
mean, it wasn't a choice. it wasn't a choice.
But I know there's also what AB, right?
Let's pretend.
There's an A, B,
There's
A, B, A, B, and then O,
And there's,
positive and negative.
B-O.
Got some cheaters there.
There's B.
How would you handle that?
Oh, why you
Those are
trying?
anchor charts, right?
Yeah, those are anchor charts. But I just brought because this part of biology is very spiritual.
Okay.
Okay, so Uncle Chat is actually a chat, but I'll try and dominant, recessive, incomplete dominant.
I'm interested in hearing about this incomplete dominant.
Co-dominant. And so,
Co-dominance?
so these are like inheritance patterns that we can co-dominant. So these are actually inheritance patterns that we can look at to show what traits you can actually inherit from your parents, what you cannot inherit. So usually you can look at a person. Are you light skin or you're white? What are you? I don't know. Good. I can look at Mr. Perry and know Mr. Perry is tall. Okay. So your phenotype, and that's like a lesson previously.
Mhm.
So what's a phenotype? Like what's a phenotype? Anybody know what a phenotype is? Mhm.
Phenotype is
Like what word is trying to come out? Like phenotype, physical.
physical trait.
Yeah.
Ah, I remember
So-
that, yes. So phenotype is like physical trait, like something you can
You
see,
can see.
like me being tall.
Yeah. But can anybody tell Mr. Perry is tall?
Yeah.
Okay. Can you tell his genotype? Can you like 100% tell what is making, like what genotype is making him tall? No. Okay. Because phenotypically, physically, he's tall, but you cannot tell if he actually had two tall genes from both parents. There's a possibility that he did, or he had one tall gene from his dad, and then like a short gene, but he's still tall. Okay. So what we're trying to say is that, and again, the anchor chart explain what dominant is in two traits you receive from both parents, which one is expressed or which one will show in the offspring's phenotype.
Mm-hmm.
Okay, so I use Mr. Perry for example. So if he got this from his dad and then this from his dad, he's tall.
Mm-hmm.
If he got this from his dad and this from his mom,
He would still be
he will
tall.
still be tall. Now, there are other inheritance patterns called incomplete dominant, where Mr. Perry here, who is the offspring, is neither showing the trait of any of the parents.
Mm-hmm.
Okay, it's not showing any trait of the parent. So the offspring in incomplete dominant is showing like a totally new form of phenotype, which is in neither of the parents.
Mm-hmm.
So he can be tall, but this offspring is not tall. The offspring is not short.
Yeah.
It could happen. If that happens, it's a condition called incomplete dominance. The offspring is not showing any trait from the parent.
Okay.
It's like a combined trait, and it's typically in animals and plants. Typically, incomplete dominance is in animals or plants.
Okay.
For example, if you have a pink flower pollinated by, or a pink flower and like a red flower produce, I don't know color, but pink and white flower produce like a
Pink and red flower.
Yeah,
produces
produce
a-
what?
well, a white and red flower.
maybe
produce-
white and red
produces
produce
a
a pink.
There we go.
The mom is, or the male is white, the female is
Red?
but the offspring
Sounds-
is not white, it's not red, but it's pink.
Okay.
That's another way we can explain incomplete dominance.
dominance.
Now, co-dominance here is another condition where both phenotypes are expressed in the offspring.
Okay.
Both are expressed in the offspring. So you have like two, a chicken, a hen and a cock. What's that called? What's the male?
Rooster?
Yeah. So if the male is white, the female is black, like all white feathers, like they have all white feathers. The female has all black feathers. They
Yeah.
have offspring, the offspring have both colors, black and white.
Okay.
So you have so like contribute, like cooperation, like bring both colors, that's expressed in the offspring. So the offspring is not showing white feathers or black, it's showing both.
Gotcha.
Okay.
So
Now,
let me ask you this. Can you compare that to like the last two, the incomplete dominance? Like let's say like, you know, we have biracial like children, right? So, you know, biracial children seem to be a mix of both skin tones. Not always work like that. But so when we're saying co-dominance, when like, you know, one of the parents are black, one of the parents are white, and the kid comes out light skinned, is that considered co-dominance?
no.
Okay.
No. So like these two, that's what I said, these two conditions are basically very typical in plants and animals.
Gotcha.
Yeah, you hardly find a co-dominant trait in humans. It's only in humans when it comes to where we are actually going.
You see that segue you did right there? That was impressive.
Because I mean, the kids ask that question, they ask that, and then that's how we get to relate that to this. Now, I know you don't have a boyfriend yet. I'll try to find you one. But if you do, what I need you to do is to find your blood group. Okay. You need to know before you start making babies. So we use what? Oh, again, Punnett square is in the Uncle Child.
Yes.
Punnett square.
All right.
We use our Punnett square to predict the possible blood groups of offsprings depending on the blood group of both parents.
Okay.
Now, do we see blood group? Can you see a person's blood group? Like, can you see it physically? Because we said a phenotype is a physical appearance, right?
Mm-hmm.
Now, you cannot see a blood group,
Nope.
but the blood group is also a form of expressed phenotype.
Mm-hmm.
When it comes to blood groups are expressed phenotype. So blood group O is a phenotype, AB is a phenotype, B is a phenotype. We don't want to go to class. It's a phenotype.
How do you see it? How do you see it?
You don't see it, it's only expressed.
How do you-
Like, it's expressed when you go to the doctor and you check and the doctor tells you you are A or you are B or you are AB. Okay. But the doctor has to check something called antigens. I think I'll come next week and then we'll come.
Yeah, let's finish this next week because we got a 4 o'clock to go to. And you had us engaged.